And it's time to begin. So the clicker is dead in here. Um, I assume it's just the batteries. Um, so, Tim, I'll just say next slide, please.
That works for me. Ah,
Oh, I see what
in
happened.
theory.
The clicker still owns the slides. That's the problem.
Yep.
All right. All right. Doing that gave me slide control. How about that? All right. Remember that we're still meeting under the note well. I am sure that it's somebody's first meeting here, so I'll just remind you that these are the rights, privileges, and responsibilities. Please don't contribute unless you're willing to follow these. And please remember, if you do not feel that we're working respectfully, you can reach out to the Ombudsman's team. So please treat each other well. We've been very good in here about disagreeing with each other respectfully, and let's continue to do so respectfully. So we got through an astounding amount of this agenda on Wednesday. We got to here. So that's pretty amazing. However, we did go through the MLDSA document and we kind of put it on pause because we were told that NIST would release a statement regarding external mu, and they did so while we were taking our nap. So that document has been shared on the mail list. And I think the situation that we have at this point is we're not waiting on anything, but I will go to the mail list and ask whether that information changes anyone's view, just to make sure. But I will start the write-up assuming that the answer is it's not changing, because that is the position that has been in the document all along. Yes, somebody's trying to go to the mic. You're having trouble getting in the queue?
Trouble's a relative word. Mike Elmsworth, so Agenda Bash, we stuck CERT Discovery slides torpedoed into the composite slides on Wednesday, and you asked us to pull them out. So it's not on this slide, but you asked us to submit slides.
Okay, that was... No, we went through these composites. You did composite SIG and composite chem together. Oh, Discovery. Thank you. Discovery. Okay. So we should add here another document, is what you're saying. Okay.
Yep.
All right. So we have only 5 to go through. Given the number that we did get through, that's pretty impressive. Any other agenda bashes? All right, we'll do these in this order and Discovery at the end. Does that work for everybody? Does that work for you, Tim?
Yes.
Okay. I will stop sharing these.
Sorry, one more Agenda Bash. Item C has my name on it. I don't think my co-authors have submitted slides. I haven't submitted slides.
All right. So you're suggesting removal of item C?
Unless Dr. Abel or Dr. Austin is here, I think we have nothing to present.
So
Okay.
you want to drop C from the agenda?
Yeah.
Okay.
Unless they're in the room and wish to speak up.
All right, Henry, you're up. The clicker doesn't work. You'll just have to tell
So
Tim
we're going to go
advance.
with the.
Yep, I will do the slides if I need to.
Okay. So my name is Henry Burgley from Princeton University. This is a
Mike.
draft. This is a draft worked on with the researchers you see here, most of them at Princeton, also Aaron Gable from Let's Encrypt. Next. So this is the CAA security tag. So I want to begin by sort of introducing the domain control validation process. So this is the process that's needed when you go to request a certificate from a CA. You have to verify that you own the domain names contained in that certificate. This involves the CA because you have to remember the applicant might not have a certificate or any type of cryptographic identifier at time of making this request. This involves the CA sending a plain text, HTTP or DNS query to the domain name servers. And if an adversary can get between that with some type of routing attack, I mostly look at BGP attacks, but you can really imagine the whole slew of on-path, off-path DNS, injecting into a TCP stream. So if you can get in between this, you compromise domain control validation. So next. So a large part of my work has been in this technology called MPIC, or multi-perspective issuance corroboration. And the idea is just to make this situation like marginally better. We specifically look at the threat model of equally specific BGP attacks, but it also helps a bit with on-path attacks and stuff. And you can imagine that if there's a local attack that's only affecting part of the internet, so here the adversaries on the red line from the CA to the domain, we have multiple perspectives now spread all over the internet. If they don't agree with the CA's primary perspective, then that blocks issuance and thus thwarts the attack. Next slide. So as I mentioned, this has some resilience to local attacks. This obviously fails once we consider a true global adversary that can be on path between any connection between the CA and the domain. And as I mentioned earlier, these are all plain text connections because the domain requesting the certificate might not have any cryptographic credentials at this time. So next. So this really brings us to the question of how can we make domain control validation robust against all types of network attackers and not require this sort of local attack assumption. The threat model I'm specifically looking at, and just because I know PKI gets quite many use cases nowadays, this is very specific to web PKI. So the browser trusted certificates signed by Let's Encrypt that rely on public DNS identifiers in them. But the goal here is to assume there's an attacker that could be on path between any connection between a CA and a domain. And to make this threat model, specific, we do have some trust assumptions. So imagine that no CAs are compromised, so no one's done a DigiNotar attack kind of. All the CAs are properly doing what the CA in browser form is telling them to do. So no, oh, I thought I was compliant, but it turned out I was signing certificates and not the right way. And then we're assuming that none of the domain's operational infrastructure is compromised. So something where like your DNS server gets hacked, that's out of scope. So we're really looking at, can we provide security against adversaries that can manipulate connections to or from a domain? So really looking at that red link in the previous slides. So next. So essentially the high level, and I think some of you might have already kind of thought of this solution, is that first you use CAA records to block all the insecure, less optimal ways of validating domains. That means that in your CAA record, and you have to use CAA extensions to do this, so that's the parameters after the semicolon in the CAA record. You either say that I'm only going to do validation via a DNSSEC protected DNS change, or you can put your account ID, an Acme account ID is bound with a cryptographic identifier. So if you put your account ID in a CAA record and only requests that are authenticated with that account can get a certificate, you essentially achieve trust. Even if you later on use a plain text validation method, an adversary that could only spoof that validation method but not sign their requests with the correct account would not be able to get the certificate. So these techniques provide protection, and then the CAA record itself obviously needs protection. So you can go out and protect that with DNSSEC. Next slide. So you may have noticed on the last slide, this depends on DNSSEC. Now, we do in our draft discuss some potential for using encrypted transport for DNS between recursive and authoritative servers. We see that as still very experimental. The sort of core of our proposal that's implementable today is using DNSSEC. And if some of you work in the CA industry, you might know that there's currently no mandate that CAs validate DNSSEC for checking CAA records. And I say this working quite closely with the CA browser forum, several CAs, and this is generally the consensus. I'm hoping it changes very soon. I'll be presenting next week at the CA browser forum face-to-face in Tokyo, a ballot draft that essentially says when you do domain control validation or CA record lookups, you have to validate DNSSEC. I think personally this is long overdue. It's been quite well supported by root programs, and I think that with the proper ballot language, I'm hoping CAs will do this. So moving on, I think it's still very important to develop technologies in a more ideal setting. There's an entire section of one of the CA RFCs that assumes, DNSSEC validation. So I think this is very important. I think this will happen. But if that's your sort of complaint, CAs don't validate DNSSEC, I think this is worth thinking about. Next. So if you assume everything I showed on the previous slides, you probably see there is a way forward for those of you who know the CAA extensions ballot, RFC. And essentially, they let you specify, as I said, account ID or validation methods. And if you look at this record set here in CAA, this sort of superficially solves the problem. So now you have example.com in a CAA issue tag. You're saying to issue only the Let's Encrypt and only have validation methods DNS01. We assume this record is signed with DNSSEC, so I just have kind of an abbreviation of the RRSIG over the CAA record. So now we have something where the CAA record is requiring secure issuance and the CAA record is protected. So with that in mind, you might think, well, why do we need another tag? And I think it's still very important. So I'll show you our proposal, and then I'm going to sort of talk about why I think that's still really important. Next. So our proposal looks really different. The idea is to define a new top-level tag. So if you know CAA tags, they have issue, issue wild, IODEF, and then the CAB form has a bunch of non-RFC tags like mail contact and phone contact. So lots of fun stuff. We're proposing a new tag called security, and security tag necessarily has the critical bit set with the intention that CAs who don't understand what this is will hard fail closed. And the specification for the tag is that anytime a CA issues under this tag, it has to take some steps to know that its domain control validation is not going over insecure plain text and actually has robustness against an on-path adversary. So essentially, the idea is to be compliant with this tag, and this can coexist with issue tags or any other CAA tags. But if this tag is in the record set, then we know you have those security properties. Next. So I want to discuss a little bit why I think this is fundamentally much better and much more extensible than the prior existing approach with RFCs. And to do that, I'm going to play a little game called Is This Domain Secure Against Network Attacks? And we're assuming every example I give will have the CAA records that I previously showed and said provided security, and then we will see if there's other stuff going on. So let's advance to the next slide. Okay, so here we have the two records I presented earlier, providing your network attack security. And this domain owner has decided to use the acmedns.io service, CNAMED for _acme challenge. And we're totally safe, right? Because the CNAME record is signed with an RRSIG, right? Next slide. So we are not safe because acmedns.io, and this is a real service that I think they don't have the hosted option anymore, but they do still have their software package available. But acme-dns.io was an Acme DNS challenge answering dedicated name server, and they ran this hosted service that does not use DNSSEC. So if you thought you had these security properties, but then you outsource your Acme challenge to a non-DNSSEC domain, you can imagine validation methods DNS01 never says it needs to be DNSSEC signed. So even though your record's DNSSEC signed, your whole zone is DNSSEC signed, you wouldn't realize necessarily that you've actually degraded your security by now outsourcing to this third party. So even though the CNAME is signed, obviously when you go to follow that CNAME, the result you get from the CNAME is not signed. So next slide. So I think this is a much simpler example. Here we have a domain that some senior administrator has put this, security configuration in, and then the new intern comes and says, "Oh man, example CA does something we like about signing their certificates. I want to use them too, so I put this line in." So I think this is a much more obvious case where if now example CA has no constraints on its issuance, then the security just gets undermined by the addition of one new record. So next. Yeah, so essentially you need to re-enumerate these attributes for every issue tag. So I think that's much less than ideal. We want to have a security stance that's really declarative and says, I want to be at this security level, not something that just happens to be that the adversary can't creatively find another way that doesn't validate that way. Next slide. So I think this is my favorite one. The sysadmin has now come in and solved the problem by adding all the same Acme account URI tags to this new CA. So now, finally, we have a holistic security level across the entire record set. Or do we? Next slide. So I think this might generate some controversy, but having spoken with many CA browser forum members, the interpretation of the RFC 8659, so this is the latest CA RFC, says the semantics of properties to the issue property tag, parameters to the issue property tag are determined by the issuer alone. Essentially what that's saying is that after that semicolon in your issue tag, you can do anything you want because you are responsible for determining those semantics. And yes, this validation methods thing, this is an RFC, but there is no reference to that RFC in the CA browser form. So when example CA gets this, they would, in theory, not have a compliance violation if they just threw out everything that went after that semicolon and said, I'm example CA and I'm authorized to issue. And you can imagine why there's problems, they don't need to agree on what the validation method is. It might not even be an Acme CA. If there's an account ID, we have the namespace considerations. So there's a neat ballot by Wayne at the CA browser forum. Might change this particular example, but I really still think it goes to show that if we want good security across any issuing CA, the right place to put it is not after the semicolon. So next. Okay, so yeah, so essentially our proposal is declarative security. You put the tag in, you have the security, end of story. If the CA sees the security tag and it understands it, it's required to honor that level of security against network attackers before doing issuance. If the security doesn't understand the tag, it gets blocked from any issuance because we set the critical bit. And then any other CAA tags, non-DNS subdomains, none of that other stuff in the domain degrades the security. Essentially, you have this policy, you protect this policy, and then you get the security. Next. So I often open with this declarative security stance because it's, at least to me, it's the most persuasive. But to quote the great infomercials of American television, but wait, there's more. Next. So the other benefit is, I think this is still a work in progress. I heard some conversation regarding this at the Acme working group, but in some optimistic future, we might see a case where we have rapid CA failover, and clients will just kind of, based on some list or some records they pull from somewhere, sort of iterate through multiple CAs to make it so Let's Encrypt no longer signs 70% of all web domains. This is an example from Cloudflare's zone. They have 3 CA partners, and as you can see, this extension enumeration problem is pretty noticeable here, where they have to enumerate their semicolon extensions on each CA. Actually, I guess 4 partners, because they said they had 3, but there's more here. But the point is that they have to sort of enumerate all these CAs that they might ever use, and they have to coordinate between the divisions at Cloudflare and say, oh, we might use this CA, we might use that CA. So next slide. So, you know, we think that this is less than optimal. This requires a domain to enumerate any CA they might use, and changing your CA records might have DNS propagation delays. So you'd rather have a DNS record that permits anybody who meets the security levels you desire. We think this hinders CA fallback. Potentially, in an extreme case, you could see a DOS risk, because now you know all the CAs that domain could use. And also, if you look at the top level of an enterprise, they might have different divisions that are going to be using different CAs, and it could be very difficult to set a CA policy. I've heard this story actually many times where, you know, enterprises are like, oh, this is my CA partner, and we only use them. But then they outsource, they get some new marketing firm, and then they just point a subdomain at the marketing firm, and then the marketing firm wants to use someone else. So we think that it's better to not enumerate CAs and to instead enumerate security properties. Next. And then the third benefit is additional validation methods. There's sort of 2 parts to this. So one is not ACME. So there's sort of some language in the existing RFC for doing non-ACME stuff. I don't think it's really a first order thing. It explicitly brings in the ACME validation methods, and it says you could write your own validation method. But once again, this kind of goes back to the it's not standardized across all CAs problem. And then the other thing is, you know, there's much more flexibility in the CAB form validation methods than there are in the ACME RFC right now. Like it or not, this is how it is. And then I think one thing I'm quite excited about is the considerations at the CAB forum to just have DCV be a static placeholder. I don't know if the ACME people will like adopt this right away, but you know, you could see a thing where there's a major market advantage to doing this if the CAB form approves it that might not get into an ACME RFC for a while. So I think it's better we're non-ACME. Next slide. We're non-ACME specific. There's still plenty of room to do this with ACME. And then the other thing is that we like to take this idea a little further. So right now, right now there's sort of 2 methods. You either specify your ACME account URI, or you specify the DNS01 validation method. We kind of see 2 interesting extensions to this. The first one is we call public key, or sometimes global owner ID in our paper. The idea is that you put in something that can identify your entity as a domain owner to any CA, and then CAs can essentially check. So like imagine this is a public key hash. You put it into DNS in a CA record, and then the CA issuing your cert says, okay, well, before I sign your cert, show me that you have the private key corresponding to this public key hash. And I think this is superior to an account ID because it's not tied to a particular CA. It's some token you could take to any CA at any time. So, you know, like if your DDoS prevention provider spins up and then you just give them this key, they can start getting certs for you. The other one, which I think I'm ready to be hated for, is one that we call existing certificate. It's a total crux. It's for bootstrapping renewals really cheap and dirty based on showing control of a prior issued certificate. Obviously, this violates the assumption I said earlier that applicants might be getting a cert for the first time. The idea is that on time 1, when you get your cert, you do something better. But maybe after that, we can essentially give you a cheap and dirty renewal by showing you have an existing certificate. Interestingly, for those of you who like doing security analysis, this has distinct security properties than the other methods because it does not prove protection against a network attacker. It proves protection against a network attacker who also has not previously succeeded in issuing a certificate. So it kind of assumes like a steady state security. Like when you turn it on, you have to have no malicious certificates out there. But I think if you ask many domains, is there a malicious certificate out there for your domain? They'll hopefully answer no. Okay, next slide. Yeah, and then as I mentioned, this is in collaboration with Let's Encrypt. They're quite interested in adopting this technique. They would like to see it go through the IETF process to, validate it, improve the methods, and then there's also an IANA registry concern with any CAA tag. So next. Yeah, so thank you so much for sitting through my talk. I'd be happy to take any questions.
Just going back to your slide with 2 and 3, the one you're going to believe you're going to be hated at.
So I think that's back one, Tim.
Back one.
The hated slide. Wait, 2. Back 2.
I love hateful things. What if 2 and 3 were vaguely the same thing, and we never involved DNS in the mix, but we simply knew to go to the domain because we're already doing that validation, and had a thing where you could just verify that there were names and a public key, and I control the public key by doing something that validates the public key, i.e. a TLS handshake.
Yes. I am actually okay with that.
Yeah.
I warn everyone I'm an aggressive practicalist. And the other thing is, I think one of the biggest chop downs on this work is they're like, domain owners never change anything. So I think we all need to be mindful of what adoption actually looks like. And if there's a way to maybe make a slight compromise at the theoretical security properties, but as you said, have a more loose wording that could encapsulate these, I'm fine with that. I would be okay with combining these.
We would probably like to cooperate with you on thinking about something that we've been thinking about similar things. And
I'd be really happy to chat.
I think there would be a way to make both of those happen that might be simpler.
Okay, yeah, appreciate that.
Tim?
Yeah, I noted this in chat, and Mike reasonably suggested I should mention it on the mic as well. The existing certificate is actually a validation method that previously existed in the baseline requirements. One of the CAs, I believe, even had some IPR around it. And so in a validation method cleanup, it was removed at some point. So you might want to go back and look. There's some previous experience there.
Yeah, that would be really helpful. Just to clarify, both of these methods are not CAB form compliant. We intend for them to be used in conjunction with a CAB form compliant method. So you can imagine they prove 2 separate things. This is proving that you have some access to a cryptographic key associated with that domain. And then the CAB form methods have a much more immediate flavor of like, yeah, you can answer a query we send to that domain right here, right now. So we think it's still valuable to use these in conjunction. Just to clarify, these only satisfy the requirements of our proposed tag. They do not satisfy either of the requirements to issue. Issuance under this model as it stands would have to be satisfying one of these requirements followed by something that's in the baseline requirements.
Microphone. Microphone. We got a lot of remote people.
All right. Any thought about a domain owner saying that they want to be authenticated via TLSA records for the?
Yeah, that's really neat. I think that might go into the previous comment about could this idea of a key for a domain owner be more broad? And I think that's fine. If the domain owner wants to authenticate to the CA via TLSA records, what we're really trying to do is introduce a sort of good security properties umbrella approach to allow flexibility for any method that will not be pwned by a plain text adversary.
Right. I mean, one of the difficulties is that right now with Let's Encrypt, many people who don't really understand exactly what they're doing publish TLSA records, but then get new certificates every time with new keys. And it would be good if the TLSA record actually matched the key that's being, authorized here, so that you get a certificate for your existing TLSA record rather than having to retrofit it after certificate issuance, which is a bit fragile.
Yeah, that would be interesting. I would have to study potential integrations with TLSA records. I think there is a lot of synergy, as Aaron kind of calls this public key approach, TLSA or DANE for CAs. But yeah, I think it could integrate with TLSA records. I'd have to do more research on the details to make sure those methods are addressed correctly.
Feel free to reach out.
Yeah, absolutely.
Hi, Rich. Hi, Rich Sauls. I assume this is being progressed in the ACME working group?
No, Aaron proposed that it come to your working group, LAMPS.
CAA goes here.
Oh, news to me. Okay, thanks.
We did the last update to it. It's not an ACME method.
Yeah, I know it's a lot more about certificate X509 stuff in here, but
Yeah,
Okay,
CAA actually existed long before ACME and was originally completely unrelated, so it's kind of a historical thing at this point.
You're up, Mob.
Just for me to be clear and make sure I grokked, you are with the new property, you could indicate I want this CAA, or I could indicate I don't care what CAA, just these properties. You can do either.
yes. So so we're a separate tag from the issue tag. So if you did want these properties and you wanted to say what CAs you wanted, you would just add the issue tags in addition, and they would be compliant with this and that.
But the tag with no issuer is fine.
Exactly. So it's just about giving flexibility, that we think security properties should be decoupled from what CAs. Some people know what CAs they want, some people don't. And that what security properties you want should just be a different conversation.
Okay, I see the queue's empty. Anything else? So what's the action here? A call for adoption? Is it ready for that? Or do you want to talk
Well,
about
I mean,
this for a while?
yeah, we would be happy to take, updates or recommendations before a call for adoption and kind of go with what the working group recommendation is in this space.
Okay, then Henry, I ask you to start a thread.
Sure. Thank you.
All right, thank you. Who's next, Tim?
Draft Van Geese signed data. I'm looking for the slides. Let's see. Oh, here it is.
I think we did those Wednesday.
You're right, I think. I don't think I have the wrong slides though, because it says draft Van Geest lamps. Did I put it in 2 spots in the agenda?
I don't. We already did those slides. That's what I know.
It was done. We have notes in the minutes.
All right. Oh, you're right. Actually, we skipped over Burghley and we did those on
Right.
Thursday. So C is gone. We're up to draft Mindell lamps PKC8. All right, got it.
Yes, Joe.
Hi, Joe Mandel. Talking about PKCS8, private key information, content types. Next slide. Well, really the only slide. So this one's kind of fairly straightforward. 59, 58 has this defined, and there are no content types for it. So what we're doing is just assigning a content type for private key info and encrypted private key info.
So people may recall that we were discussing PKCS8 when we were talking about the private keys of MLDSA and MLChem, and it was observed that the last document only assigned a content type for a sequence of private key info, and that isn't compatible with what a lot of people do. So we thought we'd make it clear that that previous practice continues to be fine. And so one of these, the first one on the slide, is just assigning the content type for a single private key info, because the document already has a content type for a sequence of private key info. And the other one is for a single encrypted private key info. That's it. Go ahead.
So you're saying that this is defining ASN1 to match the world. The world already does this.
The
We just don't have
ASN1 already
privacy.
exists in the document. This is assigning an OID if you want to carry it in a CMS.
And do people because what's in the world? What's deployed? Is this asking people to change implementations?
You don't need these to do that, but it makes it clear by doing the same thing that the document already does. Yeah, that was my reaction too.
Sorry, Sean Turner. So back in the day when we did 5958, basically we just the PKCS8 format, and it didn't have a CMS content type. So at the time, it was like, let's have a content type and you can carry multiple keys. People are like, okay, that's awesome. Did it then. Now people are like, don't do that. We don't do that. Okay. So this is defining a content type for private key info, which is PKCS8. So all it's putting is a wrapper around the PKCS8 stuff. Because if you look at the old version of what's there, it's just private key info, none of this other ASN1 stuff that now gets more used by some people. So that's all this is. It's one as opposed to more than one.
It's a one-page RC. Does anyone object to a call for adoption? Hearing none. Thank you, Joe.
All right, next is the cert discovery slides. Yep, this is it.
I guess this is me unless John shows up in his hospital gown again, which is possible.
Hey, there he is.
Ta-da!
Yeah, I am here. If you want, I can do it. I'm supposed to be getting out any hour now, so I might actually see you guys.
John.
You're fair.
Let the minute say that Sean needs to not say things. Okay, next slide. Next slide just says we did this already. We did this already. I can keep going with the slide. So we took the slides from the interim from January and we reposted them with a slide that says we did this already. Do you want us to keep going or do we stop here?
Does anyone object to a call for adoption of this document?
We do have one new slide that we added of content, but I can somewhat less sassily remind you what this is. Next slide. So this is the thing. This is what we're doing. This is the ASN1 in the document. It's adding a X59 extension that lets you point at another X59 certificate. And so it's if you wanted to issue a pair of certificates together and cross-bind them, or if you wanted to, I think it's general, right? You could say, here's a signing cert and an encryption cert, and they belong together, and you want to do something that's tighter than just DN matching. Or if you wanted to say, I'm the post-quantum version of that thing, or if you want to say, I'm RSA, but a post-quantum version of me exists over there, any reason you might want to cross-link two things. We're using a URI, so it's crawlable. This is discovery. This is a discovery draft. This is if you have one of the things, you can easily go acquire the other one. So we're not doing like cert hashes or whatever. This is really just a URI of it's over there, go get it. Yeah, and this is designed to be flexible. Next. It occurred to us, yeah, here's a picture. You can do parallel cert chains and you can cross-link them in both directions, which is cool. Next. Unless John wants to jump in. This is the new slide. Hey, Russ, this is new. You've got this private key statement thing. It occurs to me, well, let me unroll a security argument here. If I'm going to take an existing signing cert, I'm going to use that cert to attest to the possession of a private key for a chem CSR, and that chem CSR gets issued as a cert. If that first thing gets revoked for key compromise, the whole thing should get revoked for key compromise. So I'm going to suggest if you're going to stack of turtles your CSRs this way, you should probably cross-link in the certs that you did that, so you can unroll it again later if you need to revoke them backwards. So this is actually a nicely complementing mechanism on top of the thing you're proposing.
That's an interesting suggestion. Thank you.
John, I don't know if you want to. This is basically all.
Yeah, I was just gonna say, Mike and I just thought of that last night. Hey, this might actually complement Russ's draft. So I mean, this has a lot of use cases, right? Like, yeah. So that's all. I guess you could go to the next, or that's probably the end. You don't need any more details, probably.
Yeah, and these are just identical slides from the intro.
We were just comparing what's out there today to what this graph does differently. We did go through this before.
I'm happy to go to the queue at this point. I think, John, unless you want to get any specific slide in here.
Sounds good.
All right, Victor?
Yes, can you explain the intended consumers of this? Not all validators are online. Is it really intended to be processed somehow during validation, or is this for CAs only? Where does this fit into the ecosystem?
Right. So the use case that initially got us to write this draft was thinking about like SMIME. So if I've been emailing you a bunch and I've got your RSA cert in my local cert store, and then suddenly I upgrade Outlook, and Outlook says, actually, I'd prefer PQ certs now. I've got your RSA cert in your RSA cert. Can you go back, Tim, to the ASN1 slide? So we've put in here a URI, and we also put in the signature and public key algorithm. So I could look at this thing and I could say, okay, I have your RSA cert, but oh, this extension says that also an MLDSA version of this cert exists. Let me go download that, and then or maybe MLChem is a better example. If I'm trying to encrypt an email for you, I see that you have an MLChem cert. Let me go download that and use that preferentially. That was the use case that brought us to do this. And then we've it's made it a bit more generic so it could cover more things, but that's how we got here.
So are validators now expected to be online and HTTP capable?
No.
Go ahead.
I mean, if they are, they'll be able to, I guess, download it, but no, you don't have to be.
Through Nokia. If you could elaborate on the use case in the document, that will be helpful for people. I mean, for instance, right, I'm pretty sure it's not useful in WebPK world, right? I mean, I don't think that's the intended scope of this draft, I assume, right?
Sorry, can you say that again?
Like, for instance, are you intending to use it in WebPK, HTTP kind of protocols?
I don't think I can speak to that. I mean, if you're planning to issue, like, if the migration strategy for PQ is to issue multiple certs to every end entity, maybe it's useful to cross-link them. I don't have a good answer to that.
Yeah, I mean, if that's being done, right, I mean, if you can go back to the figure of the two cert chain paths, right, I don't think it gives the same non-separability property like what we get for composite signatures, right?
Yeah, no, you don't.
This is a discovery mechanism, not a security mechanism. Yeah, Tim, can you go forward one?
Yeah. For instance, this gives a good backward compatibility mode for someone in a closed environment where I have configured my peers, like let's say IPsec, right? I know my peer is supporting both the certs, and if I don't see that cert, I'm gonna disband in the IQ2 session, right? But in a world where I don't know if both the certs are being there or not there, it's pretty possible for an attacker to remove this extension and assume that there's just one cert, right? Yeah, the EE cert. Yeah.
You'll notice in the top corner, we've said backwards compatibility question mark, hybrid security question mark, discovery check. Like this is not intended to be a security mechanism. It's intended to be I have one of your certs. How do I go find the pair?
Right. Okay. Thanks.
Andrei Popov of Microsoft. So I think it's a very useful mechanism. I think there are many possible uses of this. Actually, in Windows, we have something like this for certificate renewal, where one certificate can point to its renewed certificate, and then the TLS stack can chase those links, you know, without resetting anything by the sort of operator. So there are many potential uses of this. I'm not sure that the same property should be used for all of them. I'm suspecting that we need basically different pointers for different purposes, potentially. Somehow to constrain that space, because otherwise, like I should know for what purpose I'm chasing those links. That's one comment. And another comment I have on this is, you know, for some of those things, it's important to avoid loops in that graph, so that the code chasing those links doesn't end up, because we've seen people set it up that way. Anyway.
Right, and so it's not like the case we have here. You want a cycle.
In this case,
you say
yes.
here's a pair of certs that were issued together.
Right.
The cycle is very natural,
Right.
but in other
Right.
cases you.
If you constrain it to a specific use, it may be fine to have loops. Yes.
Yeah, Henry Bridgley from Princeton University. I will say I don't for sure know if the security properties would hold, but I think there is a web PKI use case of this or something similar. Research done by some members of our group was on sort of if you have like a CA preference list, and then you would like to, you know, domains you'd like to sort of trust higher preference CAs. So there are sort of times where it might be useful in web PKI if a domain can point out to some other cert that it has, because the client might be happier with that cert. And then you could maybe re-handshake for some reason. And obviously it's not, you know, security. It does just shows the cert exists. It's just discovery, but maybe you could do something now. So not a fully fleshed out idea, but like, I think this is cool.
Yeah, we did think that it could be used for operational redundancy as a possibility. So what you just suggested was something we had pondered. So great.
So Vickers, PQ Shield. I had a question about this use case where you point from an RSA cert to an MLDSA cert or vice versa. I've not read the draft yet. I don't know what it says about the security of that, but you already, during the presentation at least, said that this is not useful for security because, of course, if you assume that RSA is broken, then you can put anything in that link or just remove it. So what's the use case exactly? Because if it's authentication of something on the spot, then either you assume that a quantum computer is breaking your stuff, or you're assuming that it's not there yet and then it's still fine to use RSA. So I'm sort of curious to see what that would actually do.
So the use case that I'd said was I've been emailing with you over SMIME for 5 years. You and I have been exchanging emails already for 5 years. So your SMIME cert is in my local laptop's trust store. I then patch my email client so that it now prefers PQ. The next time I go to email you, it'll pull up your cert and go, hey, this is RSA. Hey, wait, this RSA cert that I've been using for 5 years says that an MLDSA version of it exists. Let me go find that, and the next time I email you, I'll upgrade myself. It's a bootstrapping up mechanism if I've already been using your existing one. At least that's the use case I presented.
Right, so there's a little bit of tofu in there.
Yeah.
Right. No, that could make sense, I guess. Thanks.
Hi, Rich Sauls. I just want to emphasize what Andre said, which is add a purpose in there. I put it in the chat, but like link relations in HTTP, HTML, have it, you can have a whole bunch of reasons why you want to do that. And I think if you don't have a reason, then you're sort of limited to one. Because if you have multiple ones, you have no idea which one you want to chase. But I think it's a really good idea. I don't think we can fix that after adoption.
Would that be like a purpose registry? We need to register a list of defined purposes. I have the power.
Okay,
Excellent.
so I guess the short answer is yes, because then we wanted like a small text field that describes what the purposes are, and we can look at the link registry for examples. Yeah.
Right.
But
Purpose,
again,
alternate algorithm, purpose, whatever. Yeah.
yeah, purpose. This is also me. Yeah, that does. We can still adopt it with that and fix it then.
Purpose private key statement. Sorry? Can we have multiple links for different purposes? Yeah, you can have multiple copies of this extension, I believe. Would you like?
Hi, Mike. So here's Greeley. I can now fully follow this draft, but I once read the one, also called the related certificate. For my understanding, that one is mainly for something like, okay, save the certificate size. Yeah, because like, okay, originally I have a certificate. It may be issued by using RSA, like a traditional one. Then later, if we have one, if I need a post-quantum certificate, PQ certificate, in that case, I get a link or reference to the RSA signature. So I can save some information there. So I can retrieve some information from the RSA certificate. So I get some link inside my PQ certificate. But for this one, I don't know whether it's for the same purpose or different.
I didn't follow.
Because my point is that for the original one, I don't remember where is the authors. Maybe from CA. And
do you mean the multi-auth cert draft published by?
Yeah, it's a multi-author
NSA?
draft. Yeah, called the related certificate.
Right.
Because
Yeah.
for that one, I think it's just a one-way link.
Yes. So this
Yeah,
draft
but here
is
two-way links. Yeah.
You're correct that the history is that this draft, we looked at the multi-auth cert draft, which puts a hash of the whole cert into the next cert.
Yeah.
And so that really, so with the multi-auth cert draft, you cannot do what's on this slide right now. You cannot link both directions because you have to fully issue one cert, hash that cert, and then put the hash in the other one. So yeah, so we saw that draft. We said this concept looks useful, but it's not generic enough. So we then wrote a second draft, which is more generic.
With that being said, though, I think one of our slides we had proposed an optional hash, because if someone wanted a stronger binding in only one direction, we could support that quite easily. It's just in that other draft Mike was talking about, that hash is required, right? So that means it has to be issued first.
Okay, so one more related question
so what
is
was your
that
question?
what are you planning? Like that draft and this draft, you will like combine them together or still separate?
Completely separate.
Okay, yeah.
Yeah, that draft is already with ISG. I think that the multi-auth
Oh, I
is
see.
Starting in the RC editor.
Yeah, it's gone. And it is a complete piece of work. I mean, it accomplishes its goals, which are different goals from this one.
Yeah, great.
And yeah, as John said, I mean, we can adopt this and then we can iterate the ASN one. We can add a purpose. We can add an optional hash. We could add cryptographic binding. We can do lots of things. But the core idea is at least a URI so you can say something else exists and here's how you get it.
Yes. I'm rather skeptical about the purpose registry. I think if there are multiple purposes, there should be multiple extensions. And just wanted to mention that extensions need to be unique in a certificate. You can't repeat an extension. If an extension contains multiple data, it all needs to be within the extension. There's no support for multiple extensions in X509. So make the purposes concrete, explicit, and clear, and one extension per purpose is my take.
So we could register multiple OIDs for the extension if you wanted to do purpose tagging. We could do it.
I thought you were
Yeah.
already using
But
access,
Corey has a comment that he put in the chat, which I think he's going to mention right now.
which allows multiple.
This is all. This can all be post-adoption bike shedding. I think. Is the general concept useful? Is really the question
Right.
I want to land on.
So are we going to wait for one rev, or is it ready now for the call?
It's ready now.
Ready now.
Okay. Anyone object
I
to
mean,
that?
I think if we're going to do a big, what should the design be? That sounds like that's like adopted work to me.
Hearing no objections, we'll do a call for adoption among the other ones we've agreed to do. All right. Thank you.
Thank you.
I believe we're to any other business. Is that right? I'm not hearing any. Then we're done. Thank you very much.
It's affecting all of our brains. We don't remember why. That's what it is.
Oh, that was